Let me go, Travis. I'm feeling to sing. I'm feeling to sing. I'm feeling to sing. I'm feeling to sing. Sing happy birthday to you. Sing happy birthday to you. Sing happy birthday. Sing happy birthday. Happy birthday to. One more time, let me go. Sing happy birthday to. Oh my God! Happy birthday to you. Sing happy birthday. Sing happy birthday. Happy birthday to you.
on the CSEC lecture today. Now, we might have to do a little things backwards today because our sponsor, the ones who gave you all the good pen and books, JDIC, they had to leave and come back later. So we're going to make them do a little welcome. But as I said, we can't delay no further, right? We just need to jump in. So welcome, everyone. Please use the pens and books. We'll have a Q&A session after. We want it to be very interactive. And we're also live streaming right now on YouTube. So we appreciate all the schools and teachers who are online and who waited as well. So please welcome everybody, Dr. Ajani Asaru.
Hi, good morning everybody. How you guys ready for some math? Yeah. Alright, when do you have exam? You're in 5th formers? Most of you? When do you have exam? May 9. Math exam is May 9. That's a structured paper or a multiple choice paper? Structured paper? Okay, lovely. Well, I wish you guys all the best, alright? Alright, so as was said by Ms. Alexis, Auntie Alexis, Ajani Asaru, alright, I'm a lecturer in mathematics at University of West Indies. So, more than likely, you guys in the 5th form, so some of you may end up at UA, right? Possibly? So you skip 6th form, and if you got 6th form, fine. I suggest you probably should go. And in a couple of years, I'll see you at university. And I really hope to see you at university. I'm not just saying that. You need to get a university degree. You live in a serious world now. It's competitive. The job business, a serious business. It's 8.2 billion a year now that is competing for jobs on this globe. So you have to get yourself situated. And doing mathematics is one of the surest ways of doing that. Because we live in a world of complex problems that require complex solutions. And being STEM-oriented, right, science, technology, engineering, mathematics, is how we're solving problems, the problems that the world confronts today. Climate crisis is up on your generation. We don't know if you're going to survive it. We don't know what's going to happen in the next 50 years, 100 years. Serious thing, all right? We have to look for solutions, all right? And math is at the base of all of that. So today is just a quick overview or run through. Like I said, we don't have much time. So just for you guys, we're going to try to be as interactive as possible. Why do you think we need to learn mathematics? I kind of preempted the question. Why do you think we need to learn mathematics? What did you say? Is somebody saying here problem solving? Any other reason? Like she said, absolutely, it's a part of our what? Everyday lives, right? We can't escape that. Okay? Part of our everyday life. Your answer is spot on, as you can see right there. All right? And the fact that mathematics is a part of our everyday lives, anywhere you go in the world, any university level, any institution you go, any program that you're doing, mathematics is going to be a part of it. If you try to run from it, you're going to end up back there. So I would suggest that what? Don't run. Embrace it right now. Embrace it while you're young, right? I teach at different levels at university, undergraduate, which is, you know, the first 3 years. Typically, some students do 4-year degrees. And then we have a master's level, which is what we call, you know, postgraduate, right? And then we have, of course, doctoral level, which is after graduate, right? And in particular for the master's students, a lot of students who are in the business world and working now, a lot of them, they didn't like, well, for whatever reason, we know the story. They don't like math for whatever reason, or they're afraid of math. Let's say that. And when they get to university and they wanted to get a master's because they're in a promotion in their jobs, they end up coming back to us. So they apply to the Mona School of Business and they have to do a master's degree. And guess what? They have to go back to the math. And they're struggling, big time. These are big people. Some of them are your parents actually. These are big people we're talking about here out there in the world working and making decisions. And so I'm saying you can run, but you can't say in Jamaica you can run, but you cannot what? Hide. The truth is, you're gonna hide from math when math permeates everything. Math is in everything. So it's kind of foolish, right? Engage with it, get with it, deal with it. Because it's a beautiful thing and it is what I would say makes the world go around. So just a quick highlight. I mean, I know you know all of this, or should, I hope. Should, yeah, that's probably the right word, should. Because sometimes we think we know things that we don't really know it quite. There's some years in where mathematics, you know, just a snapshot really of some years where mathematics are involved in life. Simple stuff like gardener coming to your house to do some work, you doing some gardening yourself, mathematics is at play, all right? Decorating, remodeling your space, right? It looks good because of proportion. You might want to paint this area green, not do it so large, do it in a different shape. It gives it, its art becomes artistic. Math is in art, all right? Math is everywhere. Of course, I don't need to tell you about technology because without mathematics, there's no technology as we know it. And what is technology, by the way? What does technology really mean in a simple way, a practical way? Anybody? It does mean your cell phone? Does that mean your gadgets? Technology is a way of life. It's what we do to make our lives easier, basically. That's why we're trying to develop a nice we call it now, washing machine, so it does the job better, maybe quicker, right? So it's to make our lives easier, right? But we have to understand how nature works, how the world in which we live works, the universe in which we inhabit, how it works. And how do we understand that? Because, it's just there. We're just here and it's there. And we're trying to make sense of it. And how do we make sense of it? Through mathematics, through physics. We try to understand the physical world. Why is it that a hurricane is behaving the way it is behaving? Why is it that it's hot here and cold over there? How do we try to get a grasp of that on that as human beings? Well, we understand the physics, we understand how nature works, we observe it, and then we use mathematics to describe it. And that's why you see those equations that you see on the board. They describe how reality, how nature is behaving. And then we have those equations now. When we're trying to solve those equations, it tells us what we expect to happen or what should happen. And if these are what we call, they become models. They become models of reality. And if these models are good models, and a model is as good as how it works, if these are good models, then we can use them to make what? Predictions. And figure out what's going to happen down the road, tomorrow, next year, 5 years' time, 20 years' time. How is the population going to grow? All of that good stuff. So mathematics, without mathematics, none of that happens. Mathematics is a language through which we understand the reality that we inhabit. Okay? So, again, X-rays, CT scans, all of this stuff is high-level mathematics. But to get to high-level mathematics, you have to do what? The CSEC mathematics and the PEC mathematics, right? You have to, creep before you start walking, right? So, all of X-rays, CTs, they're developed. These technologies came out because of the work that mathematicians did, particularly in the era called numerics, okay? Numerical methods, right? Where we develop ways of solving these mathematical equations, which are actually what we call differential equations. All right, differential equations are equations, and there's some equality involved, right? Matching up quantities that are balanced nicely, and they describe how a particular phenomenon works, right? And they're what we call partial differential equations. They're because they describe how things change. And we live in a world, everything is changing as we speak. Everything is changing, right? And so we try to monitor change. So we have to solve these differential equations, and we have to use numerical methods to do them because they cannot be solved nice problems that you see in your textbooks. The ones that you see in your textbooks are nice and contrived, right? In real life, the real problems, they're very difficult to solve. But the beautiful thing is that we have a lot of methods at our disposal that have been developed over the last 400 years to solve these problems. All right? Google, right? Everybody is, I'm sure, aware of Google, and there are a lot of other search machines nowadays, right? With DeepSeek and other AI platforms, we know what's going on. A lot of matrices under there. Some big matrices, 1,000 by 1,000, million by million. And you're doing matrices at CSEC, right? Right, we can start with a little 2 by 2. You understand? Now we can extend that to other higher dimensions. But you have to get the basics. So matrix is there as you speak, working on your phone, right? They're programmed into the computer. Okay? They're at work. Alright? So the stuff that you're learning is critical. It is important. You may not see it now, you may not understand. That's why I'm talking to you, to try to get you to understand that even though you may not see the utility of the mathematics that you're doing currently, it all comes together at the end. You understand? Mathematics is integrated, everything is connected. Alright? So make sure you do your best. Alright, understanding disease behavior. Again, we model how diseases spread. For example, how COVID was spreading. The mathematicians were at play. Alright? They were modeling the behavior. Alright? How is it going to spread? material growth, population growth, that kind of things. Even psychology, you guys love to gossip and spread rumors, right? You know, even psychology we use mathematics because we have formulas that describe how stuff like rumors spread. Right? And rumors spread, right? You know that, right? You remember the so-called Chinese telephone? When you say A plus B equals C, and then you reach down the road, somebody said C plus D equals F, right? Okay, so we understand that. Of course, in the usual basic fields, I expect you to understand that math is there. Physics, chemistry, biology, these are what we call the hard sciences or the natural sciences. All right. Sports, obviously, statistics there overwhelmingly. Gambling, mathematicians have, figured that out. So as a mathematician, I'm not going to gamble because the mathematics tells me that I'm not going to win in the long run. I can't win. The house is going to win every time. You might get lucky. If you get lucky and you stop, then you're smart. If you keep going, you're going to lose by fiat. Okay? All right. Regular stuff, cooking. I mean, you think you use math in cooking? That's why the food tastes so good in this mathematical, And you put too much salt, what happens? You know what I'm saying? And if you don't put no salt, it might not taste as good as you want it to taste, right? And of course, we're talking about what here? Proportions, right? And you do proportions every day in maths, right? Yeah, proportions. You do cross multiplication. And use that terminology, which we don't like as teachers because what happens is that students, quote unquote, bastardize the term cross multiplication. Because you cross multiply when you shouldn't cross multiply. You need to know when to do it, right? You can only do it when you have the so-called proportion, which is the equality of fractions, right? So a half is equal to 4/8. Yes? Yes? Yeah, is that true? A half is equal to 16/32, right? Only because 1 times 32 is the same as 2 times 16. And 16 is itself, right? Sorry, 2 times 6 is the same as 1 times 32. 32 is equal to 32. That's why it works. Alright? We might look at the rule of 3 in a minute. I'm sure we'll get to that. So these are just some areas in which math affects us in a real sense. Alright? Managing your time, decorating and remodeling your home, all of that good stuff. And what I wanted to do here was just to, in an area like say law, which is not so obvious, that mathematics plays a fantastic role, or a mathematical minded approach plays a phenomenal role. Is a little comparison here between, what is required in law and what we do in mathematics. So it doesn't matter, like I said, mathematics makes you adaptable to the world in which you live, right? You can transfer knowledge, you can adapt to new situations. Because the truth is, a lot of what you learn at university, when you go out in the work world, you probably don't use it on a day-to-day basis. But what it allows you to do is you're trainable, you understand? And that knowledge becomes transferable to a new situation. Alright? And it allows you to think critically and also to problem solve and take a different approach. That's why when you're doing a math problem, you say, hold on, I try this and it now work out. And what you have to do, you have to find another approach. Right? Or maybe one approach is what? Less efficient than another approach. Yes or no? You might have 10 methods that work, but which one is going to get you there what? The fastest, right? Or in less steps, what we call Occam's razor, the easiest way to get there, right? Without complicating the process, right? The simplest technology is the best technology, by the way. Okay? It is. Okay. Also, lawyers have to be skilled in problem solving because if you get arrested, you want a good lawyer. You want a lawyer to get you off, right? Say that's your problem and you want to go on. Solve that problem. Yes or no? Right? And it is in fact true that a lot of law schools, they want candidates in their programs who are mathematically minded. Critical thinking, logic, reason, that's what we do. Day in, day out. That's our food, that's our staple. Okay, rational thinking, valid thinking, some reasoning, okay? That's what we do. Abstracting as well, right? So you can come up with scenarios that you would normally come up with. Think outside the box. That is what doing the mathematics enables you to do this. Your brain is being trained. It's like that teacher want to punish you and teacher give you 1,000 sums to do. You understand what I'm saying? You're being what? You're training your what? Your mind. That's where you have to put in the work. Okay? You have to put in the work. Alright? And it just becomes, after a while, it becomes almost an intuitive process. Okay? So mathematics teaches students use critical thinking as you solve problems, and you have to analyze the problem, apply it to other problems or other similar situations in exactly the same way as a lawyer has to what? Connect his case to a million other cases, because he has to look for the best, find a valid argument to try to get his client off or vindicated, as the case may be. Alright? Once you find a strategy, you have to effectively apply that strategy. So, your fifth formula, these are just some common, mathematics can be twinned with anything, even Spanish, French, even mathematics and Spanish, right? Some common twinning of mathematics though, even when you get to universal level, just to kind of give you some information. Computing and natural fit, physics, economics, but these are very, very common combinations with mathematics. So all of these areas are mathematical basis, right? So treating mathematics, a mathematics degree with these areas sometimes becomes a natural fit. Of course, like I said, you can do mathematics with anything that you so desire. Just some tips. I'm sure you've heard this 10,000 times with your teachers, but it would be remiss of me not to repeat, right? Practice often, right? It's all about what? Practice, practice, practice. Yeah, I'm sure your mother said that practice makes perfect. It is true. And you know that yourself, you're lazy a lot of times. You're lazy, right? But you know that if you sit down and put in the work, you got to do better on that exam. Alright? You're going to do a lot better. Alright? Set aside some time each day for math activities, to do some math, especially as you prepare for your examination coming up. Alright? Remember that what are you? Who are you guys? You're what? Who are you? Somebody said, you're what? Students. You're what? So what is your job? Right. So your job is what? Student. This is the job description, Is your parents going out to work and struggle and do the things out there to try to what? Make sure you have food on the table. Your job is to what? Study. So you shouldn't be complaining about it's too much homework. That's your job. 24/7, that's your job. And not only that, you're doing it to what? To benefit you down the road. Not anybody else. Ultimately, the youth's going to benefit. So you can have a better quality of life, so to speak. Alright? So, yes. Practice, practice, practice. Use whatever resources at your disposal. Worksheets, flashcards. Use the technology. Online is the end. You're fortunate to live in a world, 2025, where in a cell phone this small in your pocket, you have the entire library of the universe at your disposal, literally. When I was going to school and I was doing a project, I had to walk to Tom Library and go on the shelf when I'm doing a physics project and look for encyclopedia, look for N that or whatever, Isaac Newton. And when I take on the encyclopedia and look in there and turning and looking the page tear out. You guys don't have to do it. You just know. You just what? You just type in whatever you want and you get what? Information more than you can use. So you're fortunate. But if you use this cell phone to just gossip on WhatsApp and send messages and go on Facebook and Telegram and all that stuff, if that's what you use to do mostly, then you're just a consumer and nothing else. You think the guy who developed the telephone was doing that? He was doing coding. That's what he was doing, Coding, mathematics, what he was doing, coding. All those apps, these people who do coding. You're the consumer if all you're doing is sending emojis. That's all you're doing. Which is, I'm saying, that's fine, that's fun. You must do that too, because that's important. But when you overdo it, it becomes a problem. You become a waste man when you overdo it. So you have to balance the thing, right? Okay? So remember that. Okay. in terms of doing math, again, don't feel too pressured, right, to get the right answer quickly, all right? What's important is that you get it eventually, all right? And if you give yourself enough time, then you won't, that minimizes the pressure as well, all right? Take time to understand what is going on, the procedure, the process, all right? That's important, all right? Don't focus too much on just what is the right answer, all right? And whenever you crack a problem, big up yourself, all right? Celebrate. All right, so again, you want to develop a growth mindset. Whenever you encounter difficulties, look at it as a chance, all right, to learn and to grow. All right, by definition, learning is a struggle. Learning by definition is a struggle. If I say 2 plus 2 equal to 4, did you learn anything? Okay, you already know that. It's when I give you something a little bit more demanding and require a bit more thinking, you start there, knock your head. Then that is when you're going through the learning process, cognitively and otherwise. So learning is a struggle. So what I'm saying is that you should embrace the struggle. Don't fight it. Sometimes the things that you try to fight, if you embrace them and hug it up, it works out better and it doesn't become a fight anymore. Right? So think about that. Again, the technology is there, and it is absolutely beautiful. And those of us who know where it is coming from, we know that it's a beautiful thing, so do use it. But unfortunately, like I said earlier, a lot of your generation, you just don't know when to stop and when to quit. All right? And you use it for wrong things. All right? I use my phone all the time, but when I'm there, I'm reading, I'm getting information, I'm reading maths, I'm doing stuff, I'm researching. Right? That's what I use it for most of the time. Of course, I do the gossip stuff too and go on TikTok and laugh, but you have to know how to manage your time and the use. Okay? All right, some careers here in terms of a BSc Mathematics Education for those of us who may want to, end up doing let's say a math degree, and you may want to, in Jamaica we have a dearth of mathematics teachers, so it's something I would encourage, all right? And one of the good things that if you're doing a degree that is science related or definitely math, the government, the Ministry of Education, Jamaica, will actually give you back your money. So that's a good way. If some of you are thinking that, hey, how am I going to afford university? Here's a nice way to afford university. You get it free, you understand? All 3 or 4 years, you get it free if you do a degree, science-based, and definitely if it's math. All right? And you can take that degree and do anything with it later on. You don't have to stay there. You can take it and do anything you want and go anywhere in the world with it later on. So that is something to keep in mind, all right? So sometimes you may want to do C down the road, but you may have to travel through different roads to get there, all right? A and B. So just letting you know, all right, that's the case. That's what I was saying there. Full funding is supported by the Ministry of Education. And here are just some career paths requiring use of mathematics, and it's in different areas, and this list is by no means exhaustive. Not everything. It's a snapshot. Where there's academia, which is where I'm in at university, right? And industry, which I'm also in. Government, modeling. Modeling is trying to understand what's happening around us, and in nowadays, animation, big thing. AI, that's where we are. And software technology. All right, transportation, logistics, all that good stuff. A lot of mathematics involve operations research. All right, running businesses and finding the most efficient way of of using material and distributing labor and maximizing profit, all of that good stuff we call operations research. Okay, when you get to university, we teach you courses that deal with these things more specifically, all right, and in depth. Statistics is replete around us, whether it's sports or diseases, I want to collect data, traffic problems. If you do a degree in, let's say, maths and statistics, first of all, I know that most of you only love money, right? Right. Don't be shy. You love money. Right. Because you want to make money. And what I'm saying to you is doing a degree that has math at the base is guaranteed you're going to find a job all the time. You will never be unemployed. You will never be unemployed. If you're unemployed with a math degree, then I just can't imagine it. That seems like an impossibility. So that one not going to happen. All right? So that is what I'm saying. Statistics, math and statistics, and I mean, I could tell you so many stories. Big bucks. Right? 5-figure US dollar salaries people are making with just a basic math and stats degree. Because not very many people out of the 8 billion are doing that. And we need people with those type of skills. Right? Rigorous mathematics and applying it statistically. All right, so that was my little kind of a pep talk, giving you some information about careers and just kind of advising you how to operate and behave and comport yourselves. So you get some, you know, well, I hear the shuffling, so I don't know what to do, right? So we do have a lot of time, so I'm going to go through with some degree of alacrity. All right, so we know that the pass mark for CSEC math in Jamaica is very dismal. Very dismal. Well, last year was 30-something%, something like that. It is, yeah. And we as mathematicians, when we look at this paper, we are like, seriously, what is happening? What is happening? You know, what is happening? All right? And especially the first part of this, your typical structured paper, is normally, you know, stuff like this, which is stuff that I know you learned from primary school. Like fractions, right or wrong? Because I gave a pep talk the other day, and it's fractions. We know what fractions are, some big things. And back in CXC now, CSEC, you're getting the same fractions. And some of you are still messing up. Because a lot of you wouldn't get 2, 4 marks, easy. And how many you would, we call it now, exploit that and get those 4 marks, right? So, I wish I had a pointer, I didn't even bring mine, but that's okay. Right. So, what are your order of operations here for the first question, the A part 1? What are your order of operations? What are you going to do first then? That's what I'm asking. You're going to make sure you do what's in the bracket first, right? Okay. All right. And you know that you have, whatever fractions do we have inside that bracket? Mixed fractions. So how are you going to go about it? So you're going to turn it into what kind of fraction? Beautiful. And then after that, what you going to do? Come on, remind yourself, man, if you're not paying attention in class. You're going to look for what? A common multiple. Now, he said something a while ago. He said something and I said something a little bit different. He said what? He said about lowest, which is perfectly correct. Nothing wrong with that. But I said a common what? Multiple. What's the difference? Common multiple, lowest common multiple. What's the difference? All right, so the truth is it doesn't matter. It doesn't have to be the lowest one, right? It doesn't have to be. It just needs to be a what? A common multiple. But suppose it is not the lowest one. What's going to happen? If it's not the lowest common multiple that you choose, what's going to happen? It means that later on you will, as you said, you might have to further what? Simplify your result, right? Further simplify your result. Okay. Number 2, you're allowed to use calculator, so your calculator can help you right there, but you make sure what are your order of operations for number 2? That's what's important, because a lot of times you guys might do the wrong thing first and you end up with the wrong answer. And even when using a calculator, listen guys, this is something that is very serious. You guys know how to use the calculators? Want to practice? And by the way, let me tell you something, because I know we're Jamaicans and we love pretty things and new things. But don't make nobody send in a calculator from foreign the night before your exam. Don't carry a new calculator into what? You must get used to it first. Done, right or wrong? If you're going there with a new calculator, what's going to happen? You're there trying to figure out how to use it, confused and mixed up, right? So make sure whatever device you're working with, especially a calculator, you're very familiar with it. Just make sure it's working good so you don't break down when you're doing the exam, right? But be very familiar with it. You understand what I'm saying? Know where all the buttons are. Because exam is timed, right? That's what I'm saying? You don't want to waste too much time trying to figure out, boy, where is the cosine, this, and where is the shift button, and so on and so forth. All right. So in terms of number 2A, part 2, you're going to work out what's in the bracket on the top first. Then you're going to what? Square it. Yes? And then you're going to perform the what? The division. And your calculator should do that for you nicely. But a word of warning. You have to kind of... Suppose the calculator is giving you the wrong answer. How would you know? How would you know? Alright, so let's say for argument's sake, you did this problem and the calculator gave you the answer as 1. Would you be suspicious? Yes. Why would you be suspicious? Because you see dividing by what? 0.005, which you know is 5 parts out of 1,000, and so on. And the numerator is positive, right? Because it is squared, yes? It's always going to be positive, and so on. Okay. All right, hold on. I have the solutions for you, so don't worry yourself, You can, are they allowed to use their phones? I'm just asking the teachers. Because they can take a picture, because in the interest of time, right? So they can look at it later. All right? Or even if the teacher can take it and then share it with them later, that's fine. Okay? But I see you guys busy, but work with me here. Well, let us start this through. All right? I'll share the solutions with you in a bit, so don't worry about the solutions, all right? We don't have enough time to do the paper, all right, during this talk. But I have the solutions for you, all right? Now, let's look at question B. What I want you to do is tell me how you think about it. That's what I want you to do right now. How you're going to approach the problem, okay? So look at part B. A store is promoting a new mobile phone under 2 plans. I want to know about that, because Digital and Flow have them plan, right? Yeah? So you don't know about them things there, right? The plans are advertised as shown in the table. Plan A, Plan B, deposit in first row here, monthly installments or payments, number of months that you have to pay, and some tax, right? Some tax. So calculate the total cost of the phone plan A. How would you do that? I don't want you to tell me how you. What I want you to do is tell me how you would go about it. Because when you're doing the exam, that's what you do. You talk to yourself first. Even while you're writing, you're talking to yourself. All right, go ahead, young man. Mm-hmm. I don't care what you get. Just tell me what you do. You multiply 65 by 12. Beautiful. And you add it to the phone. Everybody agree with that? Yes, sir. Isn't that what you're doing in real life every day? Yes or no? Yes or no? When you're paying your rent, for example, and you can't ask your parents, and you go to a landlord, and the landlord say you have to pay 2 months deposit, how you work out the money? Do you have to multiply the monthly rate by 2 months, yes or no, for the deposit? And then if it's no, you're going, unless suppose him say pay 6 months rent, you have to multiply the monthly rent by 6, right or wrong? This is maths that you do every day. So when you see it on the paper, why don't write foolishness. It's the same thing you're doing every day. You see what I'm saying? So the deposit is 400, and you're going to add that to what? 65 times what? Times 12. Make sense? All right. Which plan is a better deal? And the question says, just justify your answer. Now we're talking about it. How would you know what the better deal is? You'd have to what? Compare them. Meaning you'd have to work out the computation, right? You just did plan A already. That means you have to what? Work out what? Plan B, and then what? You look at the numbers. And that's what's going to lead you now to say, boy, other plan are better, other plan are not better. Yeah? All right. Good. We're going to move along. I have the solutions for you. So when I get to that slide, you can snap a picture of teachers and show them later on. All right. So this is the solution to, okay. This is the solution to the part 1. The answer, some of you got the answer, 11. Beautiful. And for the other one, it was 7060.5. Yeah? Good? Beautiful. Right. Again, please make sure that you know how to use a calculator properly. Proper use of a calculator is paramount. You can go on YouTube and get a video and say, how do I use my Casio calculator? You understand? And it walks you through it. Okay? Or you can Google it and read it. Right? Or whatever search engine you use. I'm just using Google as an example. Okay? All right. So you can take a picture of that. Here's the next question. The solution is there. Nicely typed out for you. So that one was 1180. Plan B's, right? Now look at Plan B. What's the difference with Plan B and Plan A? Because Plan B had an interest right around, which is where what you see I have there, right? The 105 over what? 100, right? Because what was the rate again? Was 5%? 5%. Am I going in the wrong direction? Yes, I'm going in the wrong. This is it. 5%, right? 5%? And 5%. What does that mean again? Right, so the language tells you 5 per, so it's 5 every what? Cent. The word cent. Per cent. See the word cent? It means what? 100. So you probably don't know that. It's coming from the Latin, right? In French, the word for cent is what? Cent, right? Yes? It's 100. It means it's 5 per 100. You get that? 5 over every 100. All right? That's what it means. Okay? All right. And you guys you do Spanish in school? Yes. All right. You never did a third form? Or first form? What's the word for percent in Spanish? Or what's it? 100 in Spanish is what? Ciento or cien, right? Right. So that's where the cent come from, the song, right? So it's 5 per 100, okay? All right. Okay. All right, so we're getting there. So this is question 1. This is still question 1, part C. All I want to pay a light bill. Well, whoops, I'm not thief no light. Right? So you know, say you get a bill every month. So John's monthly electricity bill is based on the number of kilowatt hours of electricity that is used or consumed per month. He's charged $5.10 per kilowatt hour for use. All right. March month, 2 readings are displayed there for the month of March. One of them is at the start of the month, and one of them is at the termination of the month. Okay, as you can see very clearly, and these are the meter readings. If you actually go home and take a look at your meter, the GPS meter, you see something like this, literally. Okay, all right. Calculate the total amount that John pays for electricity consumption for the month of March. Now, just tell me how you're going to do it. Look at the question. How would you approach it? Tell me how you'd approach it. Look at it and tell me how you'd approach it. I have the solutions on the screen, so you don't have to do anything. Just tell me how you'd approach it. How do you know how much you use for the month? Because you have a reading at the start of the month, right? And you have a reading at the end of the month. Yes or no? So how are you going to know how much you use? A subtraction. What from what? The beginning value from the end value, right? Because the beginning value is going to be smaller, right? Because you're using more as you go along, right? You keep adding, right? Make sense? So it is a final number. So what's it? So you get the difference between the final, right? And the beginning. Yes? And you get how much you would have what? Used for that particular what? Month. And then now how you calculate how much you have to pay? You multiply that answer by what? The rate. And what's the rate? $5.10. Make sense? Does that make sense? You're supposed to use 20 kilowatt hour then. What much you're paying? You don't have to tell me the number. Tell me what you would do. You would multiply 20 by $5.10. Yes? All right. For the next month, April, the month that comes, John pays, now is the same problem, is the same question, you know, just that we are looking at it now from a different angle. All right, a different angle. It says, for the next month, he paid now 2,351 with 10 cents. Yeah? For consumption. Now you want to know what? What was his what? His meter reading. Think about it for a second and tell me how you're going to approach the question now. I hear an answer. Somebody say divide what? You're going to divide by the rate because you pay by the rate, right or wrong? In other words, the 2,000, what is it? 351, there was some number that was multiplied by the rate that gave you that number, right or wrong? Because that's what we did in the first part. It's just that we're going in kind of reverse direction now, right? We want to get back now to what? How many hours were what? Were consumed or used? How long you turn the light on for? Right? So you're correct. You're going to divide by the 510 and that will give you the what? The number of what? The number of kilowatt hours that were used, and then you can take it from there to, but you're not finished though. How are you going to get the reading? How are you going to get the April reading? So you're going to divide, yes, sound good. How are you going to get the reading now? The exact reading. No. You want the meter reading at the end of April. What number going to be on the meter at the end of April? That's what we want. But you just did the hard work a while ago, no? You just did the hard work a while ago. You're going to add it to what? To the March, the end of March number, right or wrong? Because when March finishes, now the meter just keep going. Yes or no? Or you going to get to April, the meter just keep going, right or wrong? Right, so you would have added that number to the what? To the end of March number, which is 03307. You get it? Make sense? All right. Beautiful. So here's the solution. You can take a snap. So, sorry, I'm blocking you. All right, so for total number of units consumed is the difference, right? As you can see here, which is 296. So you multiply 296 by the rate. For April, you divide, as you guys correctly said, and you get the consumption, right? Yes, and they're going to add this 461 to the last reading, which was 3307. Make sense? Yes, so the current reading at the end of April is going to be 3768. Make sense? Yes, sir. Everybody sees that? You see that, my friend? All right, lovely. All right. Let's keep going. Question 2. Factorize the following expressions, right? What do we mean by factorize? Make sure someone knows what we're talking about. Go ahead. No, factorizing is not simplifying. What do we mean by factorize? Or what do we do then? Let me say, what do we do when we factorize? You're looking for what? A common factor. Yes or no? The word in there is factor, right? Factorize, right? Yeah? And you know, when you multiply two factors, what do you get? What's it called? If I multiply 4 by 2, I get what? 8. And 8 is called what? 4 is a factor, 8 is called a what? A multiple, yes? So 4 and 2 are factors of what? 8. 8 is a what? A multiple of 4 and 2, right? Beautiful. So factorizing, that's what we're doing. We're looking for common factors. And as mathematicians, we love elegance. That's one of the ways of making it a little more elegant if we can factorize it and do other little stuff aesthetically. All right? So that's what we're doing in this example here, factorize completely. So what is the common factor in the first one? Quickly. You can tell me that. Quickly. All right. Y is common to both of them. That we agreed, right? All right. So let me go on the board here. So since we only have we expect we're gonna have 2 terms because of the minus, right? So you say Y is common. What else is common? Y is 6 common. can go into itself and what? 18. So we can put the 6 as well. Right? Anything else? No. All right. So what do I put a minus here or a plus here? All right, because a minus was there, obviously. And then the first term, what's going to be here? And here's a good question. Why? Because what? Because when you what? When you distribute, right, the 6y, you must get back what was the originally, right or wrong? So 6y times y would give you back there 6y squared. So in essence, hold on. So in essence, what you were really doing to get the y, how did you get the y again? How did we get this y? What you really did was this. You did what? You did 6y what? Squared divided by what? 6y. And when you do all of that little stuff, you get what? You get y. That's what you really did. Yes or no? You were just multiplying and dividing in the same instant, okay? That's what you were doing, okay? That's what's going on behind the scenes, so to speak. All right, next term, 3x. Again, this is very simple, guys. You do something like this in the exam, you can easily double check, and it don't take you 5 seconds. So you're like, okay, 6y times y, 6y squared. And then you check the one here and you say, oh, 6y times that gives me what? 18xy or yx, doesn't matter, right? If you get something different, you realize that you would have made what? An error. And it doesn't take that long to check. It really doesn't. Okay? All right, let's move along. Next example on the screen. This one is a little bit more involved, may I say. 4m squared minus 1. Again, it says we are factorizing. Any answers there? Anybody? Any take? How would you approach this one? All right, first of all, let me ask you a question. Are there any common factors there? Between 4m squared and 1. So I'm treating it like the first term, but 1. So 1 help you? Does 1 help you with anything? Isn't 1 a factor of every single number? So it doesn't help you. Right? Does 1 help you? So I don't want you to know 1. 1 is everywhere, right or wrong? 1 divides every number, 1 multiplies every number, right? So 1 is not that, it's trivial to talk about 1, okay? All right, that's fine. So, he's trying to get it a little bit bigger. So, what was it? 4m squared minus 1. That is a number that we have, okay? As a matter of fact, it's a product. Did you know that it's a product? Did you know it was a product? Even though you see a minus sign, it's a product. You know that, right? Because this is just a number, you know. When you plug in m, square it, multiply by 4, and subtract 1, all you get is what? A number. It's in that form, okay? It is a product because, how do we know it's a product? Because what are we doing? We're factorizing. Isn't that what we're doing? So we take note of factor, that means it must be a product. All right, implicitly, that's what it's saying. All right? So, let's go. Any takers for this one? So these are the people I know you'd have to pay attention in class to spot this one. So, sorry, let me go back to my original question. In the first example, it was very clear to everybody that 6 and y were what? Common what? Factors. In this question, are there any obvious common factors between 4m squared and 1? No. And like I said, 1 won't help us, so we don't need to hear about that. So what is the story here then? What is the story here? All right, so somebody said it. Say it loud for me. He's called difference of squares. That's what he's saying. This is something that you would have had to be exposed to, basically, in your class. Difference of squares. And what we observe is this. Pay attention. A minus B multiplied by A plus B. All right, let us do this the long way. We have to distribute, right? So you go A times A, and then what? A times B. So what is A times A? A squared. And what is A times B? No, A times B. So I'm using the A first. A times A. A times B. Beautiful. So I'm finished with the A, right? Because I already exhausted these two terms, yes? Now I'm going to move on to the minus b, okay? All right, so minus b times a, minus ab or minus ba, same difference, okay? What is minus b times b? Minus. So what happened here now in the middle? The terms, right? They vanish each other, right? They make each other disappear, right? I wouldn't use the word cancel, right? Because we use cancel when we do division, all right? So I have to be careful with the language here, okay? But those two terms zero out. That's what they do, right? Because 2 plus minus 2, right? What is 2 plus minus 2? What is 2 plus minus 2? All right, 2 plus minus 2 is the same as 2 minus 2, right? By the way, so you guys are a little bit hesitant there for a minute. So what I'm saying is this. In mathematics, at this level then, these basic operations, there are only two basic operations. And those operations are multiplication, which we use this symbol for. And the other one is addition, which we use this symbol for. So multiplication includes division. And addition includes what? Subtraction. You understand? Subtraction is really addition. So what happens is that when we say a minus b, what we really mean is this. A plus the number minus b. You understand? That's what we mean, okay? When we say a minus b. So when we say 2 plus minus 2, we say, all right, 2 minus 2, which makes it what? 0. It vanishes. All right? Okay. So let's go back to what we were doing here. What we were doing here is, as the young man just said appropriately, it's called difference of squares, because we notice when we multiply these types of numbers, a minus b, a plus b, just have a different sign is separating the two numbers, right? In one case a minus, in one case a plus, right? Whenever you get this type of setup, you get a difference of what we call what? Squares, a difference of squares. Okay, so difference of squares. So there are two important words in that sentence or statement. Difference and what? Squares. What do we mean by difference mathematically? A minus sign, right? And we know what a square is, right? Like a number squared, yes? So it's a difference of squares. So with that in mind now, so the beautiful thing is that, so let me see if you guys are paying attention before we move on to the question. Let me see if you're paying attention. So what is m plus n multiplied by m minus n? What's the answer? Huh? M squared minus, it's a difference of squares, yes? So that I said a while ago with a plus b, I just changed the letters to m and n, you know. I didn't do anything different. Yes? I didn't do anything different. All I did was change the letters from a and b to m and n. So let's go again. So let me write it up here. A minus b multiplied by a plus b will forever be a squared minus b squared. Once you do it one time and you realize it's true, that's it for the rest of your life. You don't have to do it again. That not change. Okay, so watch me now. Pay attention. There's maths we do, and you have to think. So m plus n multiplied by n minus m is equal to what? Beautiful. I tried to trick you, but I didn't really trick you. Is what? Is n squared minus what? You see it now? Take a look. It's the same as this, you know. It's just m plus n is the same as what? I can write it like this, n plus m, right or wrong? So it's n plus m times n minus m, which is n squared minus m squared. You seeing it better now? All I do was just rearrange these because 2 plus 3 is the same as 3 plus 2. You get it? So I didn't really change anything. So now it's minus m squared because the minus is in front of the m in this one, right? In terms of what we have here, the minus is in front of the b, so it's always going to be minus b squared, okay? All right. So let's go again now. Next one. 2y plus 1 multiplied by 2y minus 1. What's the answer? Beautiful. Come again. 2y squared, bracket squared, right? Minus what? 1 squared. That's it. Difference of squares. The first one of them first one squared minus what? The other one squared. And then you can evaluate this. What is 2y squared? 4y squared, because 2 squared is 4 and y squared is y squared. And then 1 squared is just what? It's just 1. So 1 is a perfect square, so we don't write 1 square, just write 1 all the time, right? So it can be a little bit deceptive. All right? So with that being said now, go back to number 2 and tell me what is the answer. Do we have a difference of squares there? We have, says what? So what's the answer? 2m plus 1 multiplied by minus 1. Or vice versa. You could say 2m minus 1 multiplied by 2m plus 1. Make sense? All right. Lovely. All right. Okay. Watch me now. Still doing difference of squares for a minute. Just for a minute. Okay. (16) minus 9. Factorize that for me, please. Factorize it for me. Factorize it for me. So you realize this is what? This is equal to 4 squared minus what? Beautiful. You see that? Which you can write as what? 4 minus 3 times what? 4 plus 3. And you expect the answer, which is 4 minus 3 is 1, right? Times 7, which is what? Which is 7. That's the answer you expect, right? Yes? But what I'm saying, that this is a difference of squares. That's really what I'm saying. Yes or no? Okay. All right. All right. I'm not going to trouble you anymore. I mean, I could go further, but let me leave it at that for a second. Okay? All right. Let me do that for a second. All right. So next one, number 3. Still factorizing. 2t squared minus 3t minus 2. What's your approach to this question? How do you approach it? Anybody can tell me? I mean, no your teacher them tell you, but tell me. The so-called, we call it? AC method, right? That's what they call it. Fine. So I think we're all on the same page. You don't have to call it that, by the way, but as long as you know what it is, that's what's important, right? So tell me what is the so-called AC method. See, she know the name and she know what it do. That's the problem with labeling things. So what is A and what is C? All right, so first, let me ask you this question, class, students. What type of expression do we have there? What is it called? It's called, it begins with a Q. And why? What's a quadratic again? It's an expression that what? Where what? Where the highest power in the unknown variable is what? Is 2. Right? So we have an expression in t squared, right? Make sense? So it's a quadratic, and so what you would have learned in school is how to do what? Factorize what? Quadratics, right? And why? Because quadratics are a big thing. As simple as they are a big thing. We use them quite a bit in the world that we live. like lights that are reflective lights in optics, your lenses that you wear, designing highways, we use quadratics because their shapes are called parabolas, right? Satellite dishes, you have a parabolic satellite dishes and so on, okay? So quadratics are very, very important, and we use them even in economics to model supply and demand and so on, okay? All right, so AC method, so you guys know, so a typical quadratic looks like this, ax squared plus bx plus c. I think that's what you were saying, right? Yes. Right, so everybody would have been exposed to that in school, I hope, if you were paying attention. Because I know you exposed, wasn't it? It's just whether you're paying attention or not, right? So when she said AC method, that's what she's talking about, right? It's what you're going back to, yes? All right, now. So you would have learned that if a quadratic expression, and it's an expression, it's not an equation, there's no equality there, okay? It's an expression. If a quadratic expression can be factorized, right, then the AC method works. I'm going to call it your method, your AC method, it works. Yes or no? So how do you do this now? First you multiply what? A and C, and you're going to get a number. And you kind of keep that number. You can write it down or keep it in your mind, right? Make sense? If you can't remember it, write it down. Okay? So in this case, you go 2 times 2, 4. So you kind of keep, so AC is equal to 2 times 2, which is equal to 4. So you keep that in the back of your mind, right? Next thing now, what you do? Minus 2. So it's 2 times minus 2, which gives you negative 4. All right, beautiful. So what's the next thing you do? All right, so you jump in the gun. After you finish with AC, quote unquote, who do you look at next? See, now you look at who? B. And who is B? B is the coefficient of what? Of x. The number multiplying x is called the coefficient of x, which is B in this case, right? So what's the coefficient of x here, or t? So here, B is equal to what? Negative 3. Everybody see that? Yes? Beautiful. All right, so you would have done AC, and now you'd have zoned in on what? On B. So now that you're zoning in on B, what are you going to do? Tell me what you're going to do. You're going to start again? All right, so I hear some stuff going around there. So, and you're not wrong, but it can cause confusion. Eh? If you're saying A and you're saying B, even though motive might be correct, because you're saying add and subtract, that's all right. All right. So, you focus on B. So what you want is that you want 2 numbers that add up to minus 3. So let us stick with add, make life simple. You want 2 numbers that will add up to what? Minus 3. So let me ask you a full question. How many numbers you know that add up to minus 3? It's a full question, so I want to answer though. How many numbers do you know that what? Add up to minus 3. Somebody said 3. What's the answer? What's the correct answer to the question? I'm hearing some stuff which is correct. But what is the answer to the question? How many? My question is how many? The answer is what? Infinitely what? You can't count them, right? How many different numbers add up to 10? As many as you like, right or wrong? Yes? 8 and 2, 7 and 3. You understand? I could keep going forever, right? Good. So now recognize that what? You can write a number as the sum of any 2 numbers, right? But in this method, for it to work the way we want it to work, where you can find a common factor, because that's what we're looking for, right? You're going to find numbers that what?
add up to what? The b value, which is this, in this case is negative 3. They must add up to b, and when you what? Multiply those same two numbers, you must get the same result as what? As AC. That is the key right here. They must still give you back negative 3 or the b, because you can't change the problem. But when you what? So for example, what I'm saying is that 7 plus 3 is equal to 10, and 8 plus 2 is equal to 10. Correct? Yes or no? But 7 times 3 is equal to 21, and 8 times 2 is equal to 16, right? Right? So you're going to get different values based on when you multiply those numbers, right? Yes? So when we're factorizing using the so-called AC method, what you want to do, when you focus on B, you're going to look for two numbers that add up to B, that give you back exactly B, right? But at the same time, simultaneously, when you multiply these two numbers, it must be the same as what? A times C. That's why it's called the AC method, I suspect, right? Beautiful. So now that we are experts on that, let us do the question. So what should we do here? So this is 2t squared. And you're going to have something in t and something. Which two numbers add up to minus 3? When you multiply them, you get negative 4. Negative 4 and? Right. Or you can tell me the other way around. You can say positive 1 and negative 4. It doesn't matter, right? So plus 1t, but we won't write 1t, we just write t, right? And minus what? 4t minus 2. So this guy here in the middle is the same as minus 3t. Yes or no? We haven't changed the problem. You can't change the problem, right? Yes? And then now, after that, what do we do? No, you don't group the like terms. No, that's not really what you do. We factorize by grouping. That's what we do. Okay? So, if you do the process correctly, it becomes very, very, very straightforward. So I do these two and the next two every time. If you do this, if you do that AC thing, right, it works. Add up to B. So now you go back to number 1, which we did earlier. You look for the what? Common factor between the two numbers. Right? So what's the common factor between these two first two? T alone, right? So when you pull out T, what do you have on the inside? 2T here plus what? 1, because 1, I can double check each time, right? You can go T times 1 give you T. That makes sense. And you go T times 2T give you what? Quickly check, right? Beautiful. These two now, over here, what is the common factor? So what about the negative? All right, so you're going to take out what? Negative 2. All right. And what you have here? Huh? To get back this term, what do you get? And what you have here? Plus. And let me tell you a little secret now. Stop. Relax. Relax. If you do this correctly, as we have been doing, is it anything? Is it whatever you get here in the first instance? You have to get back what? Exact same thing, because we're not finished factorizing it now. I'm going to show you in a minute. If you get something here different, then you're wasting your time. You get what I'm saying? Anything you get here, you must get the same. So as a matter of fact, you can close your eyes and write back what? The same thing. And then whatever number you put here must give about these two original values when you multiply them. Make sense? Yes? Now, you could have taken out a plus 2. Because isn't plus 2 common to both numbers? Isn't a plus 2 common to this term and this term? But you would have gotten minus inside, right or wrong? And then you would have been stuck, because you wouldn't have any common factor again. So it was best that we took out the minus 2. And then you get by the exact same term that you have over here, which is 2t plus 1. All right. So pay attention now, because we're not finished. So we have this term now, right? Yes or no? We have two terms. This is one of them over here, and this one here is another one. You got it? Which number is common to both of those terms now? The 2t plus 1 is common, so we're going to factorize it or distribute it, right? So we take out the 2t plus 1, put a bracket, and what do we have left? T here, and a what here? Minus 2. And there you go. And you can always multiply it back out to double check if this is what? Equal to the original result. Okay. All right. So, B. Write as a single fraction and simplify. How do you go about that now? You have to find out what? A common multiple, yes. Lowest one will be better, or to make your life easier in terms of simplification. All right, so what's the lowest common multiple here? 12. So tell me what you're going to get. You can do it mentally. Tell me what you're going to get. For the first fraction, what you're going to get? If you put 12 in the denominator, what you're going to get? 3 into 12? 4. And you're going to multiply 4 by the numerator, right? Yes. Well, make sure you use a bracket. So it's 4 times all of 5p plus 2, right? Yes? Your teacher tell us to use bracket? The teacher tell us to use brackets nicely and prudently. Because, pay attention. Pay attention, please. All right, 4, so I'm doing the first one. 4 times 5p plus 2. And if you write 4 times 5p plus 2. Are these the same? Are they the same? They are not the same. Sorry. They are not the same. This one, what is this one equal to? 20p plus what? And what is this one equal to? 20p plus what? Plus 2. Are those the same quantities? So you see why your bracket is important? All right. And it doesn't take much energy to write a bracket, all right? So don't be lazy. All right. Next question. A formula is given. This is transposition, they call it, right? A subject of the formula, I think. Yes? So determine the value of d when h is equal to 29. That's easy, right? You know what to do there? What do you do? So you put h equal to what? Multiply by 4. Divide by what? 5, and you take the what? Positive square root, right? All right, let's move along. Make h a subject of the formula. How do you do that? Transposition, right? So all you're doing is working in reverse. Yes or no? Meaning the reverse operation for addition is what? Subtraction. And the reverse of multiplication is what? And the reverse for square is what? Square root. Make sense? All right. And so on and so forth. So, when they say make h a subject, it means you want to have h alone. Yes or no? Lonely. Right now, h is crowded. Yes or no? But you have to do it systematically. All right? So, the first thing you may want to do is get rid of the square root. Yes? So, how do you get rid of a square root? So, you square both sides. Right? So, the left-hand side becomes d squared, and the right-hand side is the square root is now gone. So, it's 4h divided by. And then you realize the h is being divided by what? So how you get rid of the 5? What's the reverse of division? So you can multiply both sides by 5, right? Yes? So we get 5d squared equal to 4 8s. The 5 gone on the right hand side, right? And then now, the 8 is being multiplied by what? Again, what's the reverse operation of division? So you're going to divide both sides by what? And so in doing that, you get h on one side, and you get 5d squared over what? Over 4. And that is it, sufficiently simple. All right. So the solution is there for you. Take a picture. We're going to move along. So take a picture, you can share it with each other later on, right? Okay. Yes. Huh? Turn it down? No, you can't turn the AC. And you have on a sweater. All right. Here we go, guys. So we did that already. Oh, sorry. Take a picture. Take a picture quickly. Quickly, take a picture. Something fell from you. Something. All right. A little bit of sets. Universal set U is defined as is given. This notation here is called set builder notation. All right, X is in the set such that the colon means such that X is a member of N. You know what N mean? What does N mean? What does that capital N mean? Anybody? N is a set of what? Natural numbers, right? Ever heard of that? Ever heard of that? You guys ever heard of natural numbers? All right, have you ever heard of counting numbers? All right, the set of natural numbers is the same as set of counting numbers. Like the first set of numbers that human beings started using. 1, 2, they had 5 fingers, most of them, not everybody. Some people had 6. So 1, 2, 3, 4. You understand? That's why they're called counting numbers. So they are positive whole numbers, okay? And so in mathematics, use the symbol N to denote that, right? So it's natural numbers. All right. So X is between 2 and 12. Can X be 2? Can X be 2? Can X be 2? Can X be 12? Why not? Because it says strictly less than and strictly greater than. You see that? So 2 is not in the set, and what? 12 is what? Not in the set. Make sense? All right. The sets M and R are subsets of the universal set U, where we have U here. All right. So list the members of the subset M. Anybody can tell me what is in M? 1. It says X must be greater than 2. So how you get 1? Start again. 3, 5. All right. What about square numbers? 4, because 4 is 2 squared, right? What else? 9, which is 3 squared. Beautiful. Draw a Venn diagram. You guys know how to do that? Yes. All right. And part B, I can't help you here, but you have to make sure you get a graph paper, get your compass, and you practice construction, okay? It is very simple. It's a very easy what? 3, 2, 5, 6 marks. Very easy. And I'm sure you would have learned in school, but a lot of you are not very good at doing what you need to do on a regular basis. Get your graph paper, get your pencil. You see the problem? Right? Get your graph paper, your compass, and you practice it. You can even go on YouTube and watch a video and it shows you how to do it, okay? All right? You have to practice it. There's no way around it. I can't talk you through it. You understand? You have to practice it. It's drawing, okay? All right. So here's the solution for the Venn diagram one. And here's a picture of the construction, which, like I said, you have to do it for yourself. Yes, our technical drawing. Take a picture quickly. Take a picture quickly. And quickly. All right, let's move on to some functions. All right, the function f is defined as is given there, where f of x is equal to 1/3 x minus 2. So x is your input, right? And when you input a x, you get out a f of x, right? Which sometimes we call y, okay? It's the same xy, okay? So what is f of 3? It means that wherever you see x, you input what? 3. So what is f of 3? Just tell me what it is. 1/3 times 3 minus 2, right? Beautiful. What is f of minus 3? 1/3 times minus 3 minus 2. And you work those out, right? Beautiful. So, and you add them, those two results, and you get part 1, right? Yes? That makes sense? All right. Calculate the value of x for which f of x is equal to 5. How do we do that? You're going to substitute, no, x, no, not f of x. There's a difference between x and what? What is x? X is your input value, right? Your domain, and f of x is your range or your output value. So you're going to put what? 1/3 x minus 2 equals to what? And you solve that equation for x. Make sense? Make sense? All right. Number 3, calculate the inverse. You guys remember how to do that? Tell me, somebody tell me how to do it. One person, tell me how to do it. Somebody from over here. Stand up and tell me, somebody. How we calculate the inverse of a function f? Come on. Anybody over here? All right. Somebody at the back there. Who's ready? You. Somebody at the back. All right, go ahead, young lady at the back. All right, listen, be quiet so we can hear her. Go ahead. Right. So, sorry, I'm going to correct you. Just let y equal f of x. That's what you mean, right? So, hold on. Stop the talking so we can hear. Because I asked you to speak up. She's now speaking, so let her speak. But we need to hear her. She doesn't have a microphone, okay? Start again, please. Yes, see, let y equal f of x. So I'm just going to stay. No, we're talking this through, okay? So you're going to write y equal to what? 1/3 x minus 2. Everybody with that? Good. Next step. So what this means is that, I'm just rephrasing. She says all you need to do now is what? Interchange x and y. That means them change place and position, right? Yeah, that's the next step. So now, so originally we had what? Y equal 1/3 x minus 2. So interchange them, now we have what? X equals 1/3 y minus 2. You with me? Go again, go ahead, go ahead. Continue.
Yes, sir. Then after that, you will solve, and then you put...
Solve for what?
Solve for, yes, solve for y.
Solve for y, beautiful.
Yes.
So the final step is to what? Solve for what? Y. And in solving for y, you would have obtained what? This latest y is the what? Inverse of the original what? F of x.
F of x.
I will write as f to the minus 1 as of x. All right? Beautiful. Thank you. So here's a solution for you. On screen, take a pic quickly. This is what she said. This is what she said. Take a quick pic so you can consult it later on. All right. Here's the next question. it says we have two straight lines, L1 and L2. Pay attention. Very easy stuff. If you pay attention. Where line L1 intercepts the y-axis. Right? What is the x value on the y-axis? Oh, yeah, what's the x value on the y-axis? X is always 0 where? Put yourself on the y-axis. Anywhere on the y-axis, what's your x value? Always what? And if you're on the x-axis, what's your y value? All right. So what is the equation of the y-axis? What's the equation of the y-axis? X equals 0 is the answer. And what's the equation of the x-axis? Y equals 0. Beautiful. All right. So, anyway, we see the information there. What's the question? Calculate the gradient of the lines. How do you calculate gradient? How do you calculate gradient of a line? It is a change in y over what? Change in. So we say rise over run. Where rise is your vertical change and run is your horizontal change. So your vertical change is in that direction, in the y direction, right? And your horizontal change is in the x direction. So what is the gradient of line L1? You can just look at it and tell me. It's very easy. What is the gradient? So for example, from here and there, you can use that. 1, 2, 3, 4. So right there, and then 2. Right? So it's 4 over 2, right? Yes? All right. Very easy. All right, and this is done to scale basically, so you can read off the gradient. What about the line L2? What's the gradient for line L2? This one. Still rise over run. Is the gradient going to be positive or negative for L2? Look at the slant of both of them. For L1 is a positive slant, and for L2 is a negative slant. So the answer is going to be negative. You see that? Let's do the math. So let us use from here the rise. What is the rise here? From here to there. What's the rise? How many units do we have? 1, 2, 3, 4. Right here. Okay, and from here to here, 1, 2, 3, 4, 5, 6, 7, 8, right? All right, so you're going from here, which is 2, to 10, all right? 2 minus 10 is what? No. 2 minus 10 is? Right. So that's why it's going to be negative, right? So it's 4 over negative 8, right? Make sense? All right. How do you find the equation of a line? I know what that is. Y equal mx plus c is the equation of a straight line, any straight line. But my question was, how do you find the equation of a straight line? Right. Right. Okay. Well, we have the solutions there, though, so that's fine. What was I asking? What did I ask you guys? Equation of a line, right? How do you find the equation of a How do you find the equation of a line? Huh? What do you need in order to find the equation of a line? You need what? And what else? Okay. All right. That's not necessarily true, but I'll work with it. All right. So in order to find the equation of any straight line, you need what? The gradient and a known point on the line. You need 2 pieces of information. All right. Gradient and a known point on the line. Any point. All right. And then it can be written in the form y equals mx plus c. But in this case, it's very simple for you because you would have found the gradient already for what? For equation for line 1, right? What's the gradient for line 1? What was it again? No, it wasn't negative, it was positive, right? Yes? And then you can actually use the y-intercept because the y-intercept is also a point on the line, right? What's the intercept for the line 1, L1? Where does it intercept the y-axis? Look at it's there, staring at you. Where does it cut the y? Intercept means what? Cut. Where it cuts something, right? Okay, where does it cut the y-axis? All right. Okay. What are the coordinates of this point here, B? What are the coordinates? What is the x value? What's the x? You have to say the x value first. What's the x value? No, it's not 1. X value is what? And what's the y value? Right, so it's 0, 1. Those are the coordinates of that point, okay? All right. What was the gradient of line 2? What did we get again? It was 4 over what? It was 4 over negative 8, right? Which is, simplify that, negative a half. And what was the gradient for line 1, L1? What was the gradient for L1? Was it what? Positive 2? Right? All right, so what is the relationship between line 1 and line 2? L1 and L2 then? Is there a relationship and what is it? No, that's not quite a relationship. She said they intercept. They are perpendicular. Somebody said that. How do you know that? How do you know that they are perpendicular? I'm sure you would have been taught this in school. You just don't remember. Because what? The product of their gradients, I'm hearing it somewhere here. The product of their gradients is what? Right. Perpendicular lines, the products of their gradient, the product of their gradients is always negative 1. So M1 times M2 should be equal to negative 1, where M1 is the gradient of line 1 and M2 is the gradient of line 2. If when you multiply them you get negative 1, then you know that they're what? Perpendicular to each other. So M1 here was what? Was it 2? And M2 here was what? Negative or what? A half. So you go 2 times minus a half. It gives you what? Minus 1. So that's how you know. That is what the question is asking you about. I see you went silent, so most of you didn't remember that. Okay? It's a simple geometry fact, right? That perpendicular lines, the product of their gradients, give you negative 1. All right, take a picture quickly. This is a solution to the question. Oh, that's the previous one? All right, there we go. So one of them was negative a half, and one of them was 2. Okay, take a pic quickly. All right. All right. So we have a geometry. So you guys have to go back to your textbooks and make sure you revise your geometry and practice all of those questions. All right. So we have a quadrilateral here. QT is equal to QR is equal to QP, as you can see in the question. It says justify each answer. So we're going to have some giveaway for anybody who get this one right. Now some nice baskets over there. All right. So you guys perk up here and love free busy. All right. Okay, so go ahead for me. Do these questions, but remember, you have to justify your answer. You have to tell me exactly why you arrive at the answer that you arrive at. Go ahead. Here is the ultimate prize for this geometry question. A very attractive prize. Very motivating, right?
Anybody has the solution yet? Get it? All right. What did you say? You said 52?
52.
Come.
Come, let's see.
No, you have to work. You have to justify the answer. You don't get the basket just yet.
Come, young man.
All right, guys, there's still time.
Not quite correct. Not quite
Nearly. Good job, guy. Good job.
something that's, you know. Eh? First one. Sorry. Yo, sorry, explain what me do. Sorry, since our
No, talk to everybody. Use the mic and talk to everybody. Everybody want to hear you. Come, let's go. So, explain to us.
Okay. Explain that thing.
All right, he's going to explain to us what he did. Let us go. Let us listen. Go ahead.
Evening.
Good evening, sir.
Evening.
All right, guys, listen up. Quiet down.
I'm not sure if my answer right.
We don't tell us.
Okay.
Get to the point.
Okay. As I can see from R, the T to Q.
No, keep the mic. Yeah.
As I can see from R, T to Q, is an isosceles triangle, right?
Why is it an isosceles triangle?
Because then two lines right there, so. You can see it, right? Alright, equal sign. Whatever no one call it, equal sign. Alright. Since it's an isosceles triangle, two parts in it are equal.
Two parts? What do you mean by two parts?
Like two sides.
It's an isosceles triangle, therefore two of the sides are equal.
Equal, right? Since we already have 76, right? So I'm say, more than measure. Alright, this plus itself argue 156.
Correct.
They're gonna take away from the 180 because a triangle always equal to 180.
Some of the angles in the
Some of
triangle.
them in that triangle, right? After we take away, we get 26. 26 or something like that.
76 plus 76.
Whoa.
Calm down.
Oh, gosh, man.
He was correct. Just calm down. Even though his addition may be a little bit off, it doesn't matter. He was saying the right thing.
But still right.
He was saying the right thing.
One technical.
Right. So hold on. Because he said 76 plus 76, right? Which gives you what? 76 plus 76? 152. I know, but that was a little error. What he said the right thing, which was 76 plus 76. No, we're not. Hold on. It's not about correct answer all the time. If you look at a simple mistake, it's about procedure.
Working out.
Working out.
The answer no matter. Working
76 plus 76 is more important than saying 151. Okay. All right. Continue. So you say 76 plus 76. Continue. What's the next step?
They take away from 180 and then got the angle fee.
Which angle?
For RQT.
So identify RQT for me on the picture. The angle RQT. Okay, that's the correct angle. Identify the triangle RQT.
Say with me. Q. Hey, Q. It's a case of Q. And then T.
All right. Give him his prize, please.
Yeah.
Alexis, give him his prize. Give him a hand. He's a good sport.
Love free things, huh?
Thanks, guys.
All right, come, young lady. Come, you ready? You're not ready? All right, come. Oh, you're here? All right, you hold on for the third part. All right, so he's going to explain part number 2 for us. So everybody agrees, right? Hold on. Let's go, pay attention. So we have triangle RQT, right? Yes? And he said it was an isosceles triangle correctly. How do we know that? Because both of these sides have the what? Same dimension, right? And if two sides have the same dimension, then two angles also have what? The same dimension. So it would be this angle and what? And this angle, right? That would be 76 and 76. And the sum gives you 180, so you subtract that, double times that, from 180, which is what he was saying, okay? All right, he wasn't the most articulate, but he was very confident. And he knew what he was doing, right? He knew what he was doing. All right, so we're going to go to step 2 now, part 2. It says angle PRT, so we're going to let him have a microphone, please, so he can speak to us. All right, so go ahead, and I will ask questions.
Hello?
Go ahead.
Okay. So, angle PRT. So from here, right here, we're finding angle R, and it's a 90-degree angle. So
angle PR.
PRT, and where R is a 90-degree angle. So we're going to subtract the...
Why is the 90-degree angle?
Two lines in... How can I say this one? These two lines connect right here at the points. They connect at the point. Is it exactly that? So basically what
angle
I did...
PRT. Okay.
Yeah, so what I basically did is I subtracted it from 90 degrees to 76, and I got 14 degrees for angle PRT. That's what they asked for.
Okay, hold on. How did you get, why did you say it was at 90 degrees? You have to convince me why you think it is 90 degrees. Is because it look like 90 degrees? Is that what you're saying?
No, because it's two straight lines touch, connect. At the end, that's why it says 90 degrees.
Which two straight lines?
RT and TR and PR.
TR and?
PR.
No, I'm hearing TR and TR. Which one? Come again?
TR and PR.
And PR.
Yes. So as I say, 90 degrees, and a 90-degree angle is 90. Well, yeah.
The angle between them doesn't have to be 90 degrees. Why? What, I'm saying justify why it's 90.
That's mad.
So what is angle RQT? What's the measure of angle RQT? In the first example, that's 180 minus 76 times 2,
52
right?
degrees.
How much?
52 degrees.
52 degrees.
Yes.
No, will that be 52? It can't be 52. 76 and 76?
What?
And subtract that from 180.
Oh,
We get what? So angle RQT is what? 28, right? Yes? Good. What is angle RQP? Huh? No, he's at it. What is angle RQP? So pay attention. This is R, right? This is Q, right? And this is what? So which angle am I talking about when I say RQP? Which angle am I talking about? This one, right? Right? What is the measure of this angle? Because this angle is, what is this angle? So what is this angle? Right. Okay, it's angle on a straight line, right? Measure 180, yes? Yes? Okay. So you have this angle, right? Yes? All right, so continue. I'm giving him a chance. Go ahead, continue.
okay.
So that angle Q there, RQP is 120. How much you said? 180 minus. Okay.
What's the angle?
Oh, you're done. You're going to get a chance next, all right? I was asking you to come up and you didn't want to come up. You weren't ready. All right, come up, young lady. You want to explain part 3? All right, come. Here's part 3.
He's ready.
You ready? All right, go ahead. Go ahead.
Okay, so as you stated before that the angle Q is 150.
No. Which angle? You have to read the triangle. When you say RQP,
Okay, PR.
that's a triangle RQP, right?
Yes.
There's a triangle RQT as well, right?
Yes.
So you have to distinguish between the triangles. Make sense?
Yes. So angle.
So tell me which triangle you're talking about.
The angle RQT
RQT?
measures 152 degrees.
No, that's not correct.
That's what I said before.
Show me angle RQT on the screen. RQT. Angle RQT.
Okay, that measures 28. Is it 28? 28 degrees? Sure.
Yes, that's RQT. What's the measure of that angle?
28 degrees.
Right. That's all I'm asking you. Yes.
Okay.
Good. So what is the measure of angle RQP now?
Angle
Show me the
RQP.
triangle RQP. Right. Show me the triangle. Just draw the triangle. RQP. It's that triangle, right? This one. RQP, right? Yes? What is the measure of angle RQP?
152 degrees.
Right. And how did you arrive at that?
I subtracted it from 180 because on a straight line.
Right.
it measures 180.
Okay. Good. All right. Continue.
No. Somebody's.
Go ahead.
Okay.
All right. Continue now. So how you gonna get angle now? Okay. Go ahead. Continue now.
So that is another isosceles triangle.
Yes.
With the other-
Why? Justify that for us.
Because of it shows that it's equal.
Right. That's
So
okay.
I subtracted the 152 from the 180, and I got 28.
Right. So
Degrees.
so which angles measure 28?
Angle, angle R, angle P.
Angle what?
R and angle P.
In which figure? Because there are lots of figures on the screen.
PRQ.
Angle.
PRQ.
Angle PRQ. Yes. PRQ measures. That's correct.
Yeah, so I divided that by 2 to find both sides, and I got 14 degrees.
14. Come again. Why you get 14?
Because this is 2 degrees,
Okay.
the Q, and the other two, it says isosceles triangle, and that triangle adds up to 180. And the 152 minus the 180 gives you 28 degrees.
28 degrees, right?
It's an isosceles
And you divided by
triangle.
2 to get angles what?
Angles PRQ and angles QPR.
QPR and PRQ. Good. Okay. And then now to get angle PRT. Angle PRT. So look at the triangle PRT.
Angle PRT.
So you have this little piece, right? Didn't you you just found this little piece, right? And then you have this, right?
The question answer P for PRT.
PRT, yes.
Defining R. So
you need
said-
so PRT is this, all of this, right?
yes,
All of this.
yes it is.
Yes.
Oh, angle 90 degrees.
Right. So that's how you got. That's how you justify the 90.
Yeah, that's
So send the 6 plus what?
the 14 degrees.
Plus the 14. Give it a what?
90 degrees.
Give it a 19.
Okay.
Right? Okay. All right. Yes. Give him. He worked hard. He worked hard. Give him something.
Good job.
Who's ready now for the third part? All right. She's flailing to go. She's flailing to go.
All right.
All right, give her the microphone, please. It says angle. Let us look. Hold on. Angle SPT. SPT. Good. Given that SRT is that, and angle PSR is 100. PSR is 100. All right, go ahead.
Okay, everyone. So up here, so we have 76, right? And we already solved. Well, I already solved for right here, and it's 14, right? So if you add 14 and 76, you got 90. So we already have a 90-degree angle from right there to right here, right? So, so you them already tell yourself SRT equal 145. So you minus that from 90, which gives you 55, right? So you add 55 plus 100 minus from 180, which gives you 25 degrees for SPT. Does that explain it?
Yes? She left out something?
Andre?
You want to try? All right, she wants to try. Give her a try.
All right, so where she left off is that where you get the 90 right here, and then you have the so here so equal 152, right, and here equal 28. So over here, as it say, PSR equal 100, and all of here say equal 145, and we already get here is 76. So you're going to add up 100 plus 145 plus 76, and they're going to subtract it from 360 because a quadrilateral equal to 360. So 100 plus 145 plus 76 equals to 321, and then subtract it from the 360 equal 39.
Did she articulate better? But you guys are cheerleaders, you know. What was the answer? You got 39? Okay. All right, give her. She was a little bit more articulate. Yes, she explained herself a bit better. Was very clear. Yes. And what you really mean to say is that this, you said, young lady, you said a quadrilateral is 360 degrees. You mean the sum of the angles in a quadrilateral is 360 degrees. That's what you mean to say. Of course, and we're going to give our friend a basket because she gave her a valiant effort. Come on. Take a picture of the solution, guys. Take a picture of the solution. Lovely. All right. Let's look at this one quickly. Transformations. So you have ABC. Look, take a picture. You have ABC. Describe completely the transformation that maps triangle ABC to A prime, B prime, C prime. Triangle A prime, B prime, C prime. Is it a reflection? What is it? It's a rotation. Or we rotate? What direction? Clockwise or anti-clockwise? And how many degrees? All right, everybody's seen that. Good. You don't deserve a prize for that one. All right, where's the center? Yes, where's the center? Beautiful. Somebody said 0, 0, right? All right, lovely. There we have the translation vector. 4 minus 5. What does that mean? Anybody know what that means? It means that if you're moving. What does the 4 represent and the 5 minus 5 represent? That's what I'm really asking. Says how many units you're gonna what? Move in what? In the x direction. Could be right or left, right? Yes? Horizontally. And then in the 5, negative 5. Right, so it's either north or south. In this case, it's gonna be south, right? Because it's negative 5. All right. So, so you're going to probably need a graph paper for that, so I'm just going to show you. So it says on the diagram above, draw the triangle A double prime, B double prime, C double prime. Okay, so what would that mean? Somebody talk to me, what would that mean? If the transformation is 4 minus 5, what does B prime become under that transformation? What are the coordinates of B prime? Of B prime. Of B prime. Okay, what are the coordinates of B prime currently? 1, 1, right? So B double prime now, under 4 minus 5 is going to become what? Hmm? Negative? 4. Okay. All right. Let me show you what it looks like. Okay. So there it is, 5, negative 4 for B double prime. So basically, for each x, you would add, 4? And for each y, you would add negative 5. All right, so that is the translation of the triangle, or the transformation of the triangle under the transformation for negative 5. All right. Should we give away a prize for this one?
Yeah, we can.
Yeah? Yes. All right, so this is going to be the last one. All right, because we're stopped for time. No, I'm not going to give a prize for this one. I'm going to give a prize for the following one. This one. Prism. All right, so I'm going to give you 5 minutes to work it out. 5 minutes. 5 minutes. All 3 parts. You have to explain to me. All 3 parts you have to explain to me. So on the area of the triangle there, the length of the prism, if the volume is given, and we want the surface area. What about our school at the back there, a purpose school? Anybody coming to defend? You coming? All right. All right, just tell us your name and which school. Hey, shh. Quiet, please.
My name is Jonathan Bosso Diaz, and I'm from Steerton Academy.
Lovely. Welcome, Jonathan. All right, talk us through this, please.
If you find the area of ABC, first you would use the Pythagoras theorem to find AC, which is 6 squared plus b squared equal 10 squared. 6 squared is 36, and 10 squared is 100. Subtract 36 from 100, you get 64, and 64, the square root of 64 is 8. You would have a squared equal 8 and ab equals 6.
So you mean AC, the height AC is 8.
Yeah.
Lovely.
So what are the times 6 times 8, which is 48, it would be 48 cm squared.
Lovely. All right. Good.
Yeah.
All right. The length of the prism, if the volume is given, as 540.
For the, so that, so
the length of the prism, the length. So, what is the length? Show me the length of the prism.
so
Show me the length. All right. That's the length, right? Okay, good. So how do you calculate the length now if you're given the volume?
you would, if you have the depth, which is 6, and the height, which we just find was 8, we just need to times those two, then subtract it from that and find the square root.
No, not quite.
Or would you times them and find what number you can times again to get back to 540? Right?
No, my friend, not you. Let me ask you guys a question. Simple question. Listen up. Suppose I have let's say like a $20 coin, right? Right? What's the shape of a $20 coin? Circle. You know to find the area of a circle? Pi r squared. Good. Settle down. Listen up. All right. Suppose I stack 10 $20 coins on top of each other. What do I have now? What object do I have now? Cylinder. How would you calculate the volume of that cylinder? It would be what? Pi r squared times height, where the height would be the number of $20 coins that are stacked on top of each other, right or wrong? So if I put one $20 coin of one height, the height is 1 unit, yes? I put 2, the height now becomes 2. $10, $20 stacked on top of each other, think about it, the height is now 10, right? And the area of each of those coins is pi r squared. Yes or no? Yes? So the volume is a cross-sectional area. It means that wherever you slice the cylinder, you're going to see a what? A circle. Times the number of coins that I have, which give you the height, right? So the volume of the prism, it's like a prism, is always going to be the cross-sectional height. So cross-sectional area times the what? Height. Now if you look at this figure here, so I'm giving you a hint. If you look at this figure here, if I slice it here, you're looking from the side, what are you going to see? All right, when you look at from this side, what are you seeing? From the left side, from this side, what are you seeing? You're seeing a right angle triangle. If I slice it here, you see another triangle, right? So we are stacking right angle triangles, right? In the lengthwise direction, yes or no? We're stacking all of these right angle triangles in this direction, yes or no? Put them all together, you get the solid prism. Make sense? So the volume of the prism would be the area of what? The right angle triangle times the length. Make sense? And this is equal to what? 500 and what? 40. So that's the equation that you need to have. And then you work out L. All right? So, no, give him a chance, give him a chance, give him a chance.
So, sir, would you divide 48 by the 4?
So the area is what? What's the area? 6'8"?
The 6'8" would be, the area was 48. Would you divide it by the 540?
Or the other way around?
Or 540 divided by 48?
Yeah. Mm-hmm.
Which is 11 point something.
Right.
Because 48 divided by 540 would be 11.
No, it's other way around. Other way around.
140 divided by 48 would be 11 point.
Right. So it's not 48. What's the area of the triangle?
6 times 8.
No, what's the area of the triangle?
6 times.
So it's a half of that. It's a half of that. Half the base times the height.
So
Right. So it's not the 48. It's the 24, right?
Oh.
Right. But that's not the problem, though. What I wanted you to see, cross-sectional area times the length is equal to the 540. Right? So you need to find the length. So you're gonna divide the 540 by whatever the area was to get your length, right? Make sense? All right.
So when you make him,
Yes?
or Winston Jones.
No, man, it's okay. It's okay. You guys love gifts too much, man. You're getting too antsy over the gifts. Relax. Relax. All right.
So did he get the gift?
So you understanding what we're saying? So the cross-sectional area of the triangle, which is half the base times the height, right? And then now, when you add up all of those triangles, you're going to get the solid prism, right? Which in this case will be lengthwise, all right? And if you turn it upside down, you can call it height if you want, of the prism, all right? Just a matter of perspective, okay? So in this case, the triangle has area half the base times the height. Multiply that by the length equals the volume, which is 540. And then you make the length the subject of the formula, and that's what the question is asking you for. All right, did you do part 3? The area, surface area? Oh, you didn't get to there. All right.
The guy from Winston Jones.
Winston Jones, he's going to finish the explanation.
Sir, so...
Go ahead.
Excuse me. Okay, so you would basically find the area.
Oh no,
No, use the mic. Point with the other hand.
Find the area of this triangle and this one.
Well, is it not the same one?
Oh, yes, sir.
Okay.
You would use the length you found. Oh, so you would use the area, the length you found for this rectangle.
All right.
With this width to get the area here.
Area of here, what do you mean here? You mean the bottom rectangle?
Yes, sir.
The base rectangle, right?
Yes, sir. You would use, it's the same length, so you would use the 8 here with the 22.2 to get the area of the back one. And you would use the 10 times the 22.2 to get the area of the first rectangle. When you get all of them, you add up all of the areas, sir.
All right. Seems makes sense, right? It's correct.
Both of them get back, all right.
All right. We're going to give both of them baskets. Both of them. Yeah. Yeah, yeah. Okay. All right. Amen.
All right, guys, so thank you. So you guys just 1 second. I'll soon come give you a basket. So we are gone way over time, and some people have to leave. So I'm just asking, please, if all the teachers can come up. I guess we can start with Winston Jones, but before that, can I introduce Miss Charlene Hendricks, from JDIC. She's the one who has given you all the good up pen and books. And the gift baskets. So they were a sponsor for today. So if you can come this way, ma'am. And all the teachers, if you can just start lining up. Teachers, you get gift baskets, you don't want them. Oh, you get up fast now. Okay. Hold on. Okay. Yeah, hold on. No, go back. How much give teachers? All right, hold on, guys. 1 second. We just want to applaud the teachers because without them, wouldn't come here, right?
Cheer for your teachers, man. Cheer for your teachers. They make so many sacrifices for you guys. Thank you. Well, you can give me an email or something.
right, guys, so just as we're wrapping up, thanks everyone for coming. We know this was kind of a quick hurry come up and kind of end, but we have to go. But guys, there is refreshments outside for you, and JDIC has more giveaways outside. So don't leave without your JDIC giveaways, okay? And refreshment. 1 second, huh? All right, guys, I have a final gift basket. Who can sing the JDIC jingle? Up, yes, sir. Up, yes, sir. Come. She win already. Somebody else come. I'm singing it in tune, you know. Ready, go.
JBIC, protecting deposits for you and me.
Yeah, I think it's under here. Yeah. I think that's it. Wire from. Huh? The JDIC rep.
Let me talk. Mic check, Michael, well, go on.